Hello everybody. So, how are all of you? Safe at your home, enjoying various things, maybe your hobbies, maybe TV, maybe mobile, etc. etc. But the main thing is that you all must be safe and must be happy at your home. So, I am here to cover the first paper of your physics syllabus, physics of BSc semester 3. Myself is Swati Deshmukh from physics department. I hope you have seen your syllabus. The first topic of your syllabus is related with the concepts of wave and sound. It is very interesting syllabus. You have already studied many things related with the waves. So whatever we are going to cover in our session, all these things you may have already seen at your 12th standard, or that may be there may be few advanced things that we are going to cover here in this session. So what is a wave? A wave is nothing but disturbance. That means change from equilibrium position. Disturbance of what? Disturbance of particles of some medium. Disturbance of particles of some medium. For what purpose the disturbance is going on? The disturbance is going on to carry energy from one place to another place. But how is the disturbance? It is an oscillatory disturbance. That is, it is a repeated movement, repeated change of particles of medium from its equilibrium position. The change is going on to carry some form of energy from one position to another position. But the speciality is that there is just the vibrations of particles. There is not a net movement of particles that is taking place in case of a wave. So a wave is nothing but the propagation of oscillatory disturbance that carries energy from one location to another location without a net movement of particles in that medium. So what are the types of wave? There are various aspects by which we can classify wave into various types. The very first aspect is related with the direction of vibration of particles and the direction of propagation of wave. So, if we consider the direction of vibration of particles with respect to the direction of propagation of wave, a wave is classified into two main classes, that is the transverse wave and a longitudinal wave. In case of transverse wave, where the vibrations of particles are taking place perpendicular to the direction of propagation of wave. Okay, in transverse wave, the direction of vibrations of particle is perpendicular to the direction of propagation of wave, whereas in case of longitudinal wave, the direction of vibration of particles, is taking place in a direction same as the direction of propagation of wave. Okay, so in this way we can classify a wave into two different types, transverse wave as well as longitudinal wave. It is not only the direction of vibration of particles that are different for longitudinal wave and transverse wave, but there are various other facts that are not common or that are different for transverse waves and longitudinal waves. There may be a question in your exam like differentiate transverse waves and longitudinal waves. So, apart from the very first difference that there is different direction of vibration of particles with respect to the direction of propagation of wave, there are two things that are different in transverse waves and longitudinal wave. A transverse wave consists of crests and troughs. So what are crests? Crests are the maximum amplitude positions, whereas troughs are the maximum amplitude position but in opposite direction. So a transverse wave consists of crest as well as troughs. But in case of longitudinal waves, there are not crest and trough, but there are certain compressions where the density of medium is very high, and there are rarefactions where the density of medium is very low. So, in case of longitudinal waves, there are compressions and successive rarefactions. A transverse wave can travel through solid and on the surface of liquids, but it cannot travel through gases. Whereas a longitudinal wave can travel through any medium, solid, liquid, or gases. In case of transverse wave, there is no change in the density of medium. The density of medium remains same everywhere throughout the propagation of wave. But in case of longitudinal wave, as we have seen in last slide, that in case of longitudinal wave, the density of medium changes as a wave propagates through it. A transverse wave can be polarized. That means all the particles in that medium can vibrate in a single direction. But in case of longitudinal wave, the wave cannot be polarized. What are the different examples of transverse wave? These are nothing but the light waves, the vibrations in a string, that may be a guitar string also, the musical instrument string. The vibrations that we found on the water surface, the S waves of earthquake. These are the examples of transverse wave, whereas the longitudinal wave includes the sound waves, it includes the P waves of earthquake. So what are these S waves of earthquake and P waves of earthquake? So in future, if somebody asks you what type of waves we call to the earthquake waves, that is seismic waves. So seismic waves are neither purely transverse waves or nor these are the pure longitudinal waves. But the seismic waves or earthquake waves are the composite type of waves. These waves are a combination of transverse wave as well as longitudinal wave. In case of earthquake, there is such a crest and trough-like movement of earth. Side by, there are various compressions and rarefactions going on inside that earth. So we can say the earthquake wave include a transverse wave that propagate in a forward direction, what we call it as the S wave, as well as the earthquake wave include certain compressions and rarefactions that are propagating in forward direction. So a transverse wave include S wave, which is an earthquake wave include a S wave, which is a transverse wave, and a P wave, which is a longitudinal wave. Like earthquake wave, the water waves, these are also composite type of wave. So water wave include transverse waves as well as longitudinal waves. So these are the classifications of a wave. The classification that is based on the direction of propagation of wave and direction of vibrations of particles of that medium. There is another way by which we can classify wave into different types, and the way depends on the medium required by the wave for propagation. So depending on the medium required for the propagation, a wave can be a mechanical wave or it can be a electromagnetic wave. A mechanical wave must or a mechanical wave need some medium to propagate, but an electromagnetic wave does not require any material medium to propagate. can even travel through vacuum also. But mechanical wave cannot travel through vacuum. What are the examples of mechanical wave? These are the sound waves or the vibrations on the string of a wire. These are the mechanical waves. Whereas the light waves that include the whole electromagnetic spectrum ranging from microwave waves up to the gamma ray waves, all these are the electromagnetic waves. The mechanical waves are generally known as the periodic disturbance of medium. Mechanical waves are known as periodic disturbance of medium, whereas electromagnetic waves are just known as the disturbance. The electromagnetic waves are very fast. The speed of light is about 3 into 10 to the power 8 meter per second, whereas the mechanical waves have a slower speed. What is the speed of sound? It is just about 350 meters per second. So it is very much less as compared to the speed of electromagnetic waves. A mechanical wave can be a transverse wave as well as longitudinal wave, whereas an electromagnetic wave is always a transverse wave. So these are the few differences between mechanical wave and electromagnetic wave. This is how we can classify wave into different types. So whenever we have to define certain wave, we must know certain parameters that are associated with that wave. What are different parameters associated with a wave? So let us see. So let us consider a wave traveling in positive x direction. So this is the positive x direction as well as it is a time direction also. And particles are vibrating on y-axis, in the direction of y-axis. So we can say y is some function of x as well as time t. This is the x-axis at origin. It means it represents the equilibrium position of particles of that medium. One crest plus one trough, we called it as one oscillation, one complete cycle of a wave. So the very first parameter associated with a wave is nothing but a wavelength denoted by lambda. It is the distance between two successive particles that are in same phase. We can say it is a distance between crest and crest, it is a distance between trough and successive trough, or any 2 points that are in same phase. Or we can say it is the distance traveled by a wave in one complete oscillation. Time period T of a wave, capital T of a wave, is nothing but the time required by the wave to complete one oscillation. The number of oscillations made by the particle in one time period, we called it as the frequency nu, measured in the unit of hertz. Hertz. The next parameter associated with the wave is nothing but amplitude, usually denoted by small a, but sometimes capital A is also used, is nothing but the maximum displacement of particle from equilibrium position. So this is the amplitude. This is the amplitude. It is the maximum displacement of particle from its mean position. The speed of wave is nothing but distance traveled by wave in unit time. We know speed is nothing but the distance upon time. So if we consider one complete oscillation that required time period t to complete and that cover a distance of wavelength lambda within this time period capital T. So we can say if we consider one oscillation, speed is nothing but lambda by t, but 1 by time period t is nothing but the frequency. So we can say speed of a wave is nothing but the multiplication of wavelength into frequency of that wave. The next parameter, very important parameter, that is associated with a wave is nothing but the phase of that wave. The parameter phase is actually a relative concept. It gives the relation between two waves. It gives the comparison between two waves. So what it describes? The parameter phase denoted by phi. It describes the change in the alignment of two waves. It describes the change in the alignment of two waves having same wavelength and frequency. Okay, it describes the change in the alignment between two waves. How are these two waves? The waves are having same wavelength as well as same frequency. So, if there is certain change in the alignment between these two waves, then that change is represented by the parameter phase phi. So, let us consider two waves. If we look at these waves carefully, suppose at time t equals to 0, this is the starting point of wave. So, these two waves, where crest coincide with crest of another wave, trough coincide with trough of another wave. Such waves are known as the waves that are in phase. Their phase is same. Whereas in the next example, where trough of one wave coincide with crest of another wave. So crest and trough of these two waves are coinciding with one another. Crest is coinciding with trough of another wave. Crest, trough of another wave is coinciding with crest of another wave. These waves are said to be the waves that are out of phase, completely out of phase. But apart from in phase and out of phase, there will be certain in-between condition where there may be some misalignment, this type of misalignment between two waves. See, this is the starting point of green wave, whereas the starting point of red wave is here. So this much is the misalignment between these two waves, and this misalignment is described by the parameter phase. So if we have to describe the if we have to determine the phase difference between any two points. So let us consider this point and this point, crest of second wave and trough of next wave. This, if we have to describe the phase difference between this much distance, then that phase difference is determined by phi equals to x upon lambda, wavelength of that wave, x difference between these two points, x divided by lambda multiplied by 2 pi. Whatever answer will be there, that describes the phase between these two points, the crest of second wave and trough of first wave. So this is the formula to describe the phase difference between any two points. One more point that we have to remember, when we compare this green wave and red wave, okay, which wave is leading and which wave is lagging? So we can say this green wave, which is ahead of this red wave, is lagging behind this red wave. See, this is the starting point of wave, red wave. The green wave achieved the same starting point after certain time. So we can say this green wave is actually lagging behind the red wave, or we can say red wave is leading to this green wave. So these are certain parameters that are associated with a wave. In our next session, we will see how we have to express a wave mathematically. So, thank you.